Alright, now we will be looking into the sketch of this particular function which is given as y is equal to f modulus of x. So if we look into this particular graph, this is the function for y is equal to f modulus of x, right? Now what he wants us to plot is, he wants us to sketch the function of modulus of f modulus of x. Now we just need to remember one thing, that what the modulus function does. By definition, if we have x modulus, so what it will be doing is, it will go to negative x if x is less than 0, and it will go to positive x if x is greater than 0, right? Now based on that analogy, wherever our function f of modulus of x, like this particular function in the original graph, is staying below the x-axis, we will make sure that it stays above the x-axis. So this is the region which is staying below the x-axis, so it will stay above the x-axis. And similarly, that's the second region which is staying below the x-axis, so it's going to stay above the x-axis. And same is the case up here, and same is the case going to be up here, because he wanted us to plot this graph onto the sketch this graph onto the graph which is given on the coordinates which given up there. So I'll be doing that over there, and we'll try to replicate that. So my end graph would look like this. That's the region, and then we have this thing with us, and from here my graph is gonna move up, and similarly onto this half it's going to look like this, followed by this, and then it's gonna move up like this. So we end up getting y is equal to modulus of f modulus of nx. So yeah, this is what the graph actually looks like. Now let's just move to the part B. Alright, now let's just look into the part B. I have already plotted the function of over here, and now he wants us that it is given that f is an odd function. On the axis, sketch the graph of y is equal to f of x. So now we know that for the odd function we always have a rotational symmetry. So what we will be doing over here is, we are going to rotate that 180 degrees in chunks, right? So for example, if we look into this particular half which starts from this to this one, it is going to look, if I rotate this half 180 degrees, so it is going to look like this. Now if I rotate this particular chunk which is staying above the x-axis, so when I rotate that 180 degree, so it is going to look like this, right? And similarly, if I rotate the remaining chunk which exists from this region to this one, so if I rotate that 180 degree, so this will look like this, right? So this is going to be my function for y is equal to f of x. So if I just draw it through the blue pencil, so this is how my y is equal to f of x will actually look like. Alright, now let's just look into the part C1, and it's given to us in the question that we have 0 to 4 f of modulus of x dx, which is equal to 1.6, right? Now if we look into the graph of y is equal to f of x, which is drawn with a red line up here, and there is the graph of f of modulus of x which is drawn on the left side with the dotted line, and on the right hand side it's the exact same graph as of the f of x, right? So if you look into this region, the one that I shaded with the purple marker, from 0 to 4, that's the shaded region, because integration is actually the area under the curve. Now if I look onto the flip side, like onto the left hand side, it's the exact same graph, but it's actually slightly tilted, right? Like for example, if we look into the graph, it's actually the 180 degree rotation that I can see on the left hand side. So if I go by that analogy, what I will be doing is, if I want to find out from -4 to 0 f of x, it's exactly similar to what we have over here, but there is, because the region is slightly tilted, it's reflected, so I'll just write it as -1.6. so this is going to be the answer for the part I. Alright, now let's just look for part C2. if I look into this thing, I can actually break that graph into two halves, right? So first of all, I have that as minus 4 to 4 f modulus of x dx, and then I'll add that with minus 4 to 4 f of x dx. Alright. Now what I will be doing is I will be looking into the graph and try to see how can I actually find out the result for this one. So if I look into the f modulus of x function, which is given up here, right? So this region, the one that I'm shading up here, is the area under the curve, and that is given as a 1.6, right? Similarly, if I look onto the left half, which is this, so this is also 1.6 as well, right? So this means that if I further break it down from minus 4 till 0 f modulus of x, right, dx, and plus 0 until 4 f of modulus of x dx. So this is given as 1.6 plus a 1.6, right? Whereas if I talk about this one, so I found that out earlier, that if I go from minus 4 to 0 f of x dx, and similarly if I go from 0 until 4 f of x dx, so this half is given as a negative 1.6, which I found out in part 1, and this half is given as a positive 1.6, right? So these two would get cancelled out, and whatever the result that I'll get is from this half, which is going to be the 3.2, right? So this means finally that if I want to integrate the region from minus 4 to 4 f of modulus of x and then plus f of x dx, so this is given as 3.2,